Hello dear students, and this is a second video related to the arches. In the previous video we discussed about introduction part of arches. Under that, classification of arches, various parameters needed for the solving a problem. Okay, here I taken one example to solve. So I am considering, in the question they are given clearly, a 3-inch parabolic arch of span 40 meter and central rise of 6 meter carries a point load of 100 kilonewton at a distance of 12 meter from the right hinge. Full stop. Calculate 1. Reactions. 2. Bending moment diagram. Number 3. Normal thrust and radial shear at the section 10 meter from the left hinge. Okay, this is the basic question related to the analysis of arch. Okay, see, we have to calculate around 4 different parts. We can divide this one into 4. While analyzing a arch, we can divide this one into 4 different parameters, or we can say 4 different steps. First among is finding the reactions. Second one is to find out the rise equation and slope equation. Third one is to find out the bending moments. After finding bending moments, next step is to draw the bending moment diagram. After drawing the bending moment diagram, the final step is to find out the normal thrust and radial shear. Okay, these are the basic steps or basic procedure we are following to analyze a arch. Okay, based on the question, based on the question I had drawn this figure based on the question. Okay, see here I consider the arch of span 40 meters and rise 6 meters, and they are given that there is a 100 kilonewton point load which is acting 12 meter from a right hinge. Okay, this is the right and this one is the left. So 12 meter from the right hinge, and that's what I considered here. So 100 kilonewton, which is exactly at a distance of 12 meter from point B. So that is called as right hinge. Okay, so 3 hinges, one is at A, B, another one is at C. So if it is a hinge, you have two reactions. I am sorry, if it is a hinge, you have two reaction. One is horizontal, another one is vertical. So here I am considering horizontal as H, or if you want, you can consider this one as HA. Why I considered H, you came to know later. So HA and VA, here HB and VB. So our basic step is to find out these reactions. Okay, for that we are following the same procedure what we followed for the beams. Okay, I'm treating this entire entire arch as a beam, and then I'm analyzing this one. So in order to find out the reactions, we have same equilibrium equation, that is summation of f of x equal to 0, summation of f of y equal to 0, moment at any point equal to 0. Yeah, see here. So finding reaction, first I am considering f of x equal to 0. Basically we are having only two reaction, that is HA and HB. One is moving right hand side, another one is moving left hand side. HA minus HB will be equal to 0. So that indicates HA and HB are same. So that's the reason I am considering this one as capital H. That capital H we can call it as horizontal thrust. So that we will use even at the time of finding normal thrust as well as radial shear. That's a capital H. Okay. And next I am considering summation of f of y equal to 0. Summation of f of y equal to 0, that is VA, vertical reaction VA plus VB. These two are moving upwards positive, minus of 100 kilonewton. That's the equation it is. Okay, VA plus VB minus 100, that will be equal to 0. Okay, yeah, so then it will be, I'm considering this one as equation 1. Then I'm considering moment at point A equal to 0. Okay, if I consider moment at A equal to 0, these two forces will become 0, then we will get 100, and its perpendicular distance is, we know here to here it is 40, 40 minus of 12, it will be 28. That what I considered. 100 into 28, it tends to rotate clockwise positive. HB, it is acting horizontally and the line of action meets point A, so it will become 0, no perpendicular distance, that's the reason. And VB moving upwards and it tends to rotate anti-clockwise with respect to A, and its perpendicular distance is 40. That what I considered here. 100 into 28 minus VB into 40, that will be equal to 0. VB is 70 kilonewton. Substitute in this equation, you will get VA as 30 kilonewton. Yeah. Now you have a difficulty here how to find out capital H, because you know VA as well as VB, but you don't know how to calculate capital H. For that, we know anyhow moment at any point equal to 0. So here I am following the same procedure here. So I am considering moment at C equal to 0 for left hand side, or even if you want, you can consider for right hand side also. Any side, either it may be right hand side or it may be left hand side. I am considering about left hand side. Why? Because right hand side we have another load, so it may be difficult if you consider right hand side. So I am considering left hand side. So left hand side C, with respect to C, left hand side, these are the portion we have. Okay, so C, we have two forces, one is HA, another one is VB. HA, horizontal force, line of action is this, perpendicular distance is 6 meters, and VB anyhow C is exactly at the center, so center means here to here distance is 20 meters, because total distance is 40, here to here it is 20. 20 multiplied by perpendicular distance is 20 and multiplied by VB. Okay, that what I considered here, that you can see. Moment at C equal to 0, left hand side, minus HA into 6 because it is anti-clockwise, plus VA into 20, that will be equal to 0. So H value is 100 kilonewton. H means both side it is same, that is HA will be equal to HB, so I am considering both it as H. Okay, after finding VA, VB and H, now we have to calculate the reaction for that. So reaction, or we can say resultant of VA and H and resultant of VB and H. For that, say I considered this is support A, or you can see from this arch, this is support A, support A at the hinge, or we can say hinge at A. So we have HA as well as VA. HA is nothing but H here only. So for these two forces we have to find out a resultant RA, and even here it is same. So for these two forces we have to find out the resultant RB. Okay, so that's what I considered here. So first I am considering H and VA. So their resultant force is RA. So resultant force will be equal to sum of horizontal square plus vertical square, that is sum of all the horizontal forces square plus sum of all the vertical forces square. Here we have only one horizontal force, it is H square plus VA square. This will be the resultant force. Of that I am considering it as RA, and its direction will be as I given here. I am considering this one as theta 1. So tan theta 1 will be equal to vertical by horizontal, vertical component by horizontal component. So this will be its direction. Similarly, even we can solve for the another one, that will be with respect to RB, same procedure. RB will be equal to root of H square plus VB square here. So this is its magnitude, and similarly we are following for the direction. So if you solve up to here, that shows that you have finished the resultant part. So you have finished the reactions part. Next step is to find out the rise as well as slope equation that I told in the beginning itself. So we know it is a parabolic arch, 3-hinged parabolic arch. So that's the reason we know a rise equation y will be equal to 4h into x divided by L square whole multiplied by L minus X. Okay, this is the rise equation what we have. So if you have any doubt, we are for parabola we are following this one as a rise equation, where h will be equal to rise, where h will be equal to rise, so that will be 6 meter, that's the given in the question. L is a span, so that one is a 40 meters. If you substitute that one, you will get the value equation y will be equal to 0.6x minus of 0.015 x square. So this is called as a rise equation. And if you differentiate this one with respect to x, you will get the slope equation. If you differentiate this equation with respect to x, you will get the slope equation. Dy by dx will be equal to tan theta, that will be equal to 0.6 minus 0.03x. You will get, we will call this one as slope equation. After finding rise as well as slope equation, next step is to find out the bending moment. For that, we are following the procedure, we are following the sign convention, that is horizontal force always we are considering it as negative, whereas vertical force moving upwards produces positive bending moment, moving downwards produces vertical force moving downwards produces negative bending moment, moving upwards produces positive bending moment, whereas horizontal forces any direction you consider it as negative. Okay, this is a procedure we are following to find out the bending moment, or in order to calculate bending moment diagram. See, wherever hinges are there, at that point we will consider bending moment will be always equal to 0. That is, at point A we have a hinge, so bending moment will be 0. At point B we have a hinge support, so it will be equal to 0. At point C we have a hinged support, so it will be equal to 0. So bending moment at A will be 0, bending moment at B will be 0, bending moment at C will be 0. Okay, this will be there for all the, it will remain same for all the arch problems. Okay, at the supports it will be always equal to 0, at the hinges it will be always equal to 0. Okay, after finding this one, wherever the load is given, okay, you have to find out bending moment at the loaded point. In the question, if you see, the load is given in the right portion of the arch. Okay, that is that what it is shown here, that what it is shown here. So it will be 100 kilonewton which is acting at this point, that is right portion of the arch, and I am considering this one as D. Okay, in order to find out the bending moment, I am considering only this portion. Okay, that what I shown here. Okay, bending moment for the portion D to C, so that what I shown here. The vertical distance I am considering this one as YD, and horizontal distance anyhow they are given, it is 12 meter, and we know horizontal force it is 100 kilonewton, that is H, and we know VB it is 70 kilonewton. Okay, bending moment with respect to point D, 100 kilonewton is acting at point D, no perpendicular distance, it will become 0, and horizontal force 100 kilonewton. So anyway, horizontal force you consider it as a negative, 100 multiplied by its perpendicular distance will be YD, or you can say Y. Okay, and VB for this perpendicular distance it will be 12 meter. Okay, clear now? So that what I given here, bending moment at point D, that is VB into 12 minus of H into YD. Okay, we don't know what is YD, so for that we know the equation of rise, y will be equal to 0.6 x minus of 0.15 x square, that we get it from the previous equation per previous step, and we are substituting x value as 12. Okay, because it is a horizontal distance with respect to either any one of the bottom supports. Okay, so it is load we are considering with respect to C, so that's the reason I am considering it as 12. If you want, even you can consider with respect to another one, and also you will get the answer, nothing to be worried. Okay, oh sorry, this x will be remains same, it is 12 only, not that one. Distance I am talking, perpendicular distance you can consider another one side, but x will remains the same, x distance is 12. If you substitute here, you will get the YD value in this equation. If you substitute x as 12, you will get YD, that's a vertical distance, that is 5.04 4 meters. Okay, then after getting yd, you substitute in the above equation, that is in this equation yd value as 5.04 and h value as 100, vb value as 70, then you will get this value. This is the bending moment with respect to the point D where the load is acting. In another one portion, that is A to C. So in the A to C portion, there is no load. Okay, there is no load in the A to C portion. For that, the procedure will remains the same, but we have to identify where we will get the maximum bending moment. Okay, where we will get the maximum bending moment means at the point, if you partially differentiate the bending moment diagram, bending moment, it will be equal to 0, then at that point you will get the maximum bending moment, and that we will see in the portion A to C. See, this is A to C, only this portion I am considering. I am considering a point with respect to axis xx because I don't know where we are getting the maximum bending moment. So that's the reason I am considering this axis as xx, and for this point, for this axis, I am considering vertical distance as yx. Okay, we don't know the value, that we have to identify, and even we don't know what is its horizontal distance. I am considering this one as small x. I think you cleared here. Okay, I cleared here. Okay, now I am finding bending moment with respect to this point. Okay, so left hand side horizontal force we have, one vertical force we have. Horizontal force negative, this vertical force moving upwards produces positive bending moment. Okay, that what I written here. VA multiplied by perpendicular distance, I am considering it as x, minus of horizontal force, so it is negative, multiplied by its perpendicular distance is yx. So here unknown is x as well as yx, but we can substitute in this equation and we can make this one as a single unknown. If you substitute the y value, that is the rise equation, this is the rise equation. If you substitute this one, you simplify this equation, you will get this value. Okay, if you partially differentiate with respect to x, this equation, if you partially differentiate this one, then you will get the value of x, that what I shown here. Okay, so we know that partial differentiative of maximum slope will be equal to 0. So partially differentiate the equation, minus 30 plus 3 into x will be equal to 0, then x value will get it as 10. Substitute that one in the above equation, you will get bending moment diagram as minus 150 kilonewton meter. Okay, negative sign indicates it is negative bending moment. So in order to write the bending moment diagram, write the arch as it is. If it is negative, you have to write negative. If you got the negative bending moment, it should be written downside the arch, and if it is a positive one, it should be written above the arch. Okay, that's what I given here. So I written arch as it is, and we know bending moment at this point is 0, bending moment at this point is 0, bending moment at this point is 0, and we know bending moment at a point in a portion A to C maximum we are getting as 150, that is negative, so I written downside the arch. And we know in portion C to B we are getting maximum bending moment at the loaded point, that is 100 kilonewton load, so that has 336 kilonewton meter. So this will be positive, so I am writing above the arch, and I am drawing the inclined line for this too. And even there is no load means you have to draw the inclined line. Here point load also inclined straight line. Okay, that's what I had drawn. If it is a UDL, it is a curve, as you know. Okay, after drawing the bending moment diagram, next step is to find out the normal thrust and radial shear. For that, they are given in the question. You have to find out normal thrust and radial shear at 10 meter from left hinge. Okay, that you have to keep it in mind. So you have to find out with respect to left hinge. So left means it is point A, and I am considering here to here as a 10 meters distance, and I am considering this vertical length as Z. So vertical point as Z I am considering. So here to here this one I am considering it as Z, so it is a point where we are finding the normal thrust and radial shear left side the arch. Okay, it is at a distance of 10 meter. So left side of the arch we have horizontal force, and we H value, you know, it is 100 kilonewton, and we have VA, its value is 30 kilonewton. We know normal thrust, this is a formula. Radial shear, it is a formula. Here you know H value, unknown is V as well as theta. So in order to find out theta, we know slope equation. Tan theta will be equal to, this is a slope equation we know, where in place of x value they are given very much clearly, it is with respect to 10 meter distance. So substitute 10 in place of x, and substitute similarly h as well as L value what we substitute for the previous problem. You will get the slope, that is you will get the theta by using slope equation. And in order to calculate the vertical shear, so vertical shear means vertical forces only we have to consider. A to 10 meter portion I am considering it as Z right now. A to Z, whatever vertical loads we have to consider. We have only one load, that is VA, and it is moving upwards positive, so its magnitude is 30 kilonewton. So vertical force, vertical shear capital V will be equal to only one force we have, vertical force in the portion A to Z, that is VA, so that only we have to consider, and it is moving upwards, so positive. VA I am considering it will be equal to, V will be equal to VA, and that will be equal to 30 kilonewton. If you have any doubt, you can see this figure also, but what I shown here. Okay, in this figure I shown. Okay, after finding unknown values, that is theta, V, then substitute all the values in this equation, you will get normal thrust as well as radial shear. Okay, this is the procedure what we followed in order to analyze a arch, that is 3-inch parabolic arch. First step is to find out the reaction. Next step is to find out the rise and slope equation. After finding rise and slope equation, next step is to find out the bending moments. Then you have to draw the bending moment diagram. Then you have to find the normal thrust and radial shear. Okay, this is the procedure we are following. Thank you. We'll see some more problems in the next video.